Welcome in the second section of our course. In this section, we'll be building a regression model with Spark. So we'll be leveraging what we achieved in the previous section. We saw that we extracted features from our data. In this section, that features will fit our machine learning models to train them and achieve results. Firstly, there will be an explanation of logistic regression. This is one of the most simplest but yet most useful algorithm for performing machine learning. We'll be writing logistic regression model per author in Apache Spark. So we'll see how it will behave. So we'll be training our regression model. Also, we'll go through key concepts of machine learning pipelines and operation. At the end, we'll learn how to validate models using cross-validation. And in this first video, there will be an explanation of logistic regression algorithm. So firstly, there will do comparison between supervised and unsupervised machine learning. We need to make that distinction because they are totally different algorithms from each other. Next, we will see what logistic regression is, and we will go through a simple example of logistic regression to understand how it behaves and how to validate reality based on data. So, firstly, let's do a simple distinction between supervised and unsupervised learning. In the first part, supervised learning operates on the data that needs to be labeled. So we are fitting that data. So if you are training supervised learning algorithm, we need to fit it with a labeled data. So for example, it will be a vector of numbers and label 1 or 0. For unsupervised learning, the input is totally different. It is not labeled, so we cannot extract if something is proper or not. We need to perform some kind of a clustering based on the maybe a lot of different factors to try to group those things together to extract value. So logistic regression is from that first part. It is supervised learning. Data that we want to analyze is labeled binary, 1 or 0. So for example, in our use case, input could be vector of numbers labeled binary. So we transformed it using word2vec, and then our task will be to label it 1 or 0. So if we have a vector of numbers, text, we can label it if it was written by an author or not. If it was, we are just labeling with 1. If not, we are labeling it with 0. So this will be our task to take features, label it properly, and pass to logistic regression, and logistic regression will figure out everything else for us. But let's go through the simple example. Let's say we want to build a logistic regression model that gives us a probability of exam pass by the student. So for example, the input for that algorithm needs to be labeled. So input will be twofold. First part of the input is hours of study, how many hours student studied, and second part is if he passed exam or not, 1 or 0. So for example, input data can be the following. So if the student was learning half an hour, it didn't pass, so it is labeled with 0. If almost 1 hour, also didn't pass. 1 hour didn't pass. If one student learned 2 hours, that student passed. Then 2.5 and 3 didn't pass. 5.5 hours it passed. 5 hours it passed as well. And a lot of such labeled data can be an input to logistic regression. We can fit that up model with that data, and then result will be looking something similar to it. So if the student studied for 1 hour, the probability of passing exam is 0.12%. If 2, then 0.33. If 3, 0.52%. If 4, 0.77%. If 5, 0.92%. And also, for our finding authors, this will be an output. So for the specific form data, the output will be that author A had probability 0.12, for example, then other author higher probability, and so on, from 0 to 1 max.